Today, we're diving into a mystery that pops up almost everywhere you look. We're going to explore a really powerful new hypothesis that tries to explain why the world seems to run on the 80-20 rule. You ever get that feeling? That in just about any situation, it's always a handful of things that have the biggest impact? It's almost like it's some kind of a universal law, but where does it actually come from?
You might know this as the 80-20 rule or the Pareto Principle, and seriously, once you see it everywhere. Something like 20% of people hold 80% of the wealth. Get this, just 20% of the words we use make up 80% of our daily conversations. In any store, 20% of the products are probably making 80% of the money. It just goes on and on.
Yeah, this is way too common to be just a coincidence, right? It's some kind of deep, fundamental pattern baked into the world. And that's the big question we're tackling here. Why? What's the engine driving this pattern?
So there's our mystery. The 80-20 rule is this constant, almost predictable pattern of imbalance that shows up all over the place.
To even begin to answer this, we've got to zoom out, way out. We need to look at a much bigger idea. Not just about money or sales, but about how pretty much everything changes.
The theory we're about to unpack has a fascinating premise. What if the key to understanding this one specific pattern is to understand the pattern behind all change? And that brings us to the work of researcher Kevin L. Brown. He asks this exact question, and he's proposed a framework that might just give us the answer we're looking for.
He calls his framework triune harmonic dynamics, or THD for short. The core idea is actually pretty simple, but it's incredibly powerful. It suggests that all change, literally everything, from galaxies forming to a market evolving, happens in a repeating three-phase cycle.
So what's this cycle? Well, it always begins with a base phase. That's the start. Then it moves into a pressure phase, where things get amplified. And finally, it hits an integration phase, where the whole system settles down into a new, stable form. So just remember, start, amplify, and settle.
Okay, so how does a three-step cycle explain our 80-20 mystery? Well, this is where it all connects. It brings us to the main event, the concentration hypothesis.
And here it is, this central claim, straight from Kevin L. Brown's work. The theory is that these 80-20 patterns happen because systems have this built-in tendency to recursively amplify asymmetries. Basically, they take tiny little differences and make them bigger and bigger over time, until a concentrated state is the most stable place to be.
Okay, let's put that in plain English. What it's really saying is that any time you have a bunch of things interacting with each other, could be people in an economy, companies in an industry, whatever, any small, random advantages that exist at the very beginning will naturally get magnified over time. And here's the kicker. Perfect equality is actually really hard to maintain. It's unstable. So the path of least resistance for any system isn't to stay equal. It's to concentrate. The system naturally falls into an 80-20-ish pattern because that's its most stable, low-energy state.
So, let's walk through this process. How exactly does a system go from a bunch of random, tiny differences all the way to that predictable 80-20 outcome? It all starts in phase one, which THD calls the base phase. Picture a brand new marketplace. Pretty much everyone is starting on a level playing field. But there are always going to be tiny, random differences. A little bit of luck here, a little extra skill there. Then we hit phase two, the pressure phase. This is where those tiny differences start to snowball. The early winners get a small advantage, and that advantage helps them win again. It's a feedback loop. Success breeds success. A product gets a little popular, so it gets more shelf space, which makes it even more popular. The small differences are getting amplified. And finally, we get to phase three, the integration phase. The system doesn't just keep amplifying forever. It eventually settles down into a stable state of imbalance. And guess what that looks like? Yep, our 80-20 pattern. It's called a structural attractor because the system is just naturally pulled toward it, kind of like a marble rolling and settling at the lowest point in a bowl.
Now, here's what makes this so interesting. This isn't just some neat story or a philosophical idea. It's being put forward as a real scientific hypothesis. And that means one thing. It has to be testable.
You see, a huge principle in science is something called falsifiability. It's a fancy word, but it just means that for an idea to count as scientific, there has to be some kind of experiment or observation you could do that could prove it's wrong. So, how could we test this one? Well, the test is actually really clear. The hypothesis holds up if we keep seeing that these interacting systems, from economies to ecosystems, consistently fall into that 80-20-like pattern as they grow. But if we can find even one example of a system like this that scales up and grows while staying perfectly even, then the hypothesis is proven false. It's that simple.
Okay, this is more than just a cool science thought experiment. If this hypothesis turns out to be right, it could really change how we think about solving some of our biggest problems, especially anything to do with inequality.
The way we usually do things is we try to fix inequality directly. We treat the symptom. But if this hypothesis is right, we might need a whole new approach. Instead of fighting against a natural tendency, we'd have to focus on managing the underlying forces that cause this concentration to happen in the first place. It's a huge shift from fighting the outcome to actually tuning the system itself.
And that leaves us with a huge, fascinating question to chew on. If this 80-20 pattern really is the natural, stable state for complex systems, then maybe the goal isn't to erase it. Maybe the real challenge is, how do we build societies, economies, and organizations that work with this tendency to create systems that can be both efficient and fair at the same time?